morning, children. We proceed on to the second chapter, integration. Now, what do you mean by the word integrate? The word integrate means putting together. Last year, we have learnt differentiation. See, for example, x square is there. If I want to write the derivative, we use the formula 2x. X square becomes 2x. X cube becomes 3x square. So like this, we learnt very many formula. This year, we are reversing the process. See, in mathematics, whenever I say plus 7, that is adding 7, the reverse process is minus 7. And whenever in a problem I multiply by 7, I also divide by 7. So these are reverse processes. For addition, subtraction is the reverse. For multiplication, division is the reverse. For exponentiation, logarithm is the reverse. Similarly, for differentiation, integration is the reverse. If I integrate this dx, I take to the other side and integral and differential will get cancelled. So, integral of dx, my integral of 2x, my answer is x square. Now, we must specify a formula for this. So, there are very many formula under integration, but we are having a very little formula to be used in our textbook. The very first one is x power n, any number. So, x power n will become x power n plus 1 by n plus 1. This n should not be minus 1 alone, because if n is minus 1 plus 1 will become 0. So, in mathematics, let us ensure that we do not bring denominator to be 0. So, this formula I can apply for all n. N can be fractions 1 by 2, 1 by 3, 2 by 3, or n can be plus numbers or minus numbers except minus 1. I can put n any power for which I can apply this answer. And now remember, we said x square became 2x. Suppose in my question x square plus 7 is there. What happens? X square plus 7, x square becomes 2x, but 7 becomes 0. The constant, 7 comes also 0, 5 comes also 0, plus 7 comes also 0, minus 7 comes also 0. So let us remember, any constant that became 0 in differentiation, I should introduce in integration. So we do not know whether 5 was in the question or 7 was in the question or a half was in the question. So generally put plus c after applying the formula of integration. The c we call integration constant. So the integral constant represents the constant which became 0 in differentiation. So in this chapter, integral calculus, we say the word calculus means pebbles. Okay, in those days people use small pebbles for calculating, remember. So the small pebbles that they used, we are telling calculi. That calculi only we call in calculus. So calculus has two different branches, say differentiation and the other one is integration. So in 11th standard we learned differentiation and this year we are learning integration. The word differentiation, putting into parts, okay, putting into minute particles, we are segmenting. Whereas the word integration tells all these minute particles that we segregated, we are putting together. The word national integration, the idea of oneness and feeling. So integration means putting together, or in other words, summing up. This summing up is up to infinity. Okay, ordinary addition. See, I give you 3 chocolates, 2 chocolates, 4 chocolates. Anybody can add and tell me. But if I give you minute particles, say small tiny particles which I give you and I tell you add and tell me. So this addition is enabled by integration. So integration means summation. This S we write is sum. This S only is elongated and written this symbol. So integration is nothing but elongated summation, addition only, but addition up to infinity. We start exercise 2.1, integrate with respect to x. Whatever is the question given, call it as I. And put this symbol, this is symbol of integration. Root of 3x plus 5 into what will come? Dx. Remember, in differentiation dy by dx we wrote. That by dx we take care here. So in all the integration problems, whenever I put this integral symbol, integral, I will write dx. This represents I integrate with respect to x. Now to do the problem, let us remember this formula. Integral x power n dx. Integral x power n dx becomes x power n plus 1 by n plus 1. Instead of x, any combination may come like this. For example, 2x plus 7, 4x minus 5, some x, okay, some number into x plus some number or minus some number can come. In that case, I apply the same formula. See, integral 3x, root of 3x plus 5 means it is 3x plus 5. Whenever root comes, I call it 1 by 2. And I apply this formula. Instead of x, 3x plus 5 is there. So treat it as a bracket. Instead of x, 3x plus 5. So 3x plus 5 whole power. N plus 1. What is n here? 1 by 2. So 1 by 2 plus 1 by 1 by 2 plus 1. And whenever I integrate, I must put plus c. Now, if it is x, the formula is over. If it is 3x, remember to put 1 by 3. Let us recall in differentiation. If 3x is there in the question, I put into 3 whenever I differentiate. So in integration, 3x is coming in the question. Apply the formula, then put divide by 3, or I will remember 1 by 3. Supposing 2x is coming in the question, 1 by 2. Supposing 4x is coming in the question, 1 by 4. So apply this formula and then put 3x means 1 by 3. Now let us simplify the problem. This is 1 by 3. 3x plus 5 whole power. Half plus 1. 2 plus 1. 3 by 2. Denominator also the same half plus 1 will become 3 by 2 plus c. Denominator 3 by 2 reciprocate. So I will write 1 by 3 which is here into 3 by 2 will go as 2 by 3 into 3x plus 5 whole power 3 by 2 plus c. Now this becomes 2 by 9, 3x plus 5 whole power 3 by 2 plus c. Remember to write I, that is the assumption in the very first step. So every integral problem, we are just going to apply the simple formula which we read. Integral x power n dx is equal to x power n plus 1 by n plus 1 plus c. This n can be fraction, plus number, minus number, anything other than minus 1 because denominator should not become 0. Question number 2. I is equal to 9x square minus 4 by x square the whole square. Can I apply this formula? X power n dx is equal to x power n plus 1 by n plus 1 plus c. Mustn't forget. Now, can I apply this formula directly? In integration, there is no product rule, quotient rule, all that. So, whenever you have a whole square, expand it. So integration is done only in the last step. Let us remember, we have to simplify the problem maximum using algebra, and then only I can integrate. So remember what formula I am going to use. A minus B the whole square. A minus B the whole square. What is the formula? A square minus 2AB plus B square. So I becomes integral A square 9 the whole square 81 x square is x power 4 minus 2AB. 2 into AB is 9x square and B is 4 by x square plus B square is 16 by x power 4 dx. So my first step is not integration, simplification. So A minus B the whole square I have done. Simplify this further. This is 81 x power 4 minus 4 9s are 36 into 2, 72. X square will get cancel plus 16. This x power 4 will go to the numerator as x power minus 4. And now I have 3 terms with plus minus symbol and all. Addition is allowed in integration. You can integrate first term separately, second term separately and third term using this formula. So I becomes 81. The coefficient you keep as it is. X power 4. What is x power 4 formula using this? X power 4 plus 1 by 4 plus 1 minus constant means I will treat it as x power 0. So apply the formula 0 plus 1 by 0 plus 1, that is x. So every time you remember 5 comes in integration 5x. 7 comes in integration 7x. Here dx means put that x near that. Now here 72 is coming, which will become 72x plus 16 into x power minus 4. Apply the formula x power minus 4 plus 1 by minus 4 plus 1. And I have completed all the 3 terms. Put plus c. Simplify this again. So I is equal to 81 x power 5 by 5 minus 72x plus 16 x power minus 4 plus 1 minus 3 minus 4 plus 1 minus 3. Now denominator we don't keep minus, so put it in the power. So here I change it as minus, here I change it as plus c. So this is my answer. If you need one more line I can write x power minus 3 will come down as x power 3. So that is the answer.